So it's my pleasure to introduce my former colleague and friend, Jeff Bonwick. Jeff hired me right out of school into Sun to work on ZFS, and he definitely you enticed me with the promise of creating a brand new file system, which we did, and you did not mention the opportunity to become famous and rich beyond my wildest dreams. One of those two things has come true. It's not the getting rich one. With that, thanks for coming here, Jeff. I think is this the first time that you've talked publicly about ZFS
since the SSD, yeah.
Yes, in the past 5 years. So glad to have you here and talking about how ZFS came to be.
Right, thanks. So this is a little weird. We're basically all here because of a typo. The whole birth of ZFS, as so many software projects, began in a moment of anger. And what had happened was we had this building server called Jurassic, which we were using to serve up, this is at Sun, to serve up home directories for everybody. And it was at the time running UFS as the file system and SVM, the Solaris Volume Manager, to manage all the disks. And during the course of a sort of routine little administrative operation, someone mistyped a command, I won't name him, Mike Sullivan, to one of these SVM commands, and it was just a one digit off in the name of some meta device. And everything came crashing down because the device mapping was now wrong, so UFS was seeing wrong blocks from the file system. The whole building, like 1,000 people, was now just completely down, unable to get work done. And so while we were sitting there waiting for restore to happen, I walked over to Tim Marsland's office, who was another engineer at Sun at the time, and we just sat down and just started harping and complaining about, I've been here since 1990, Sun's been saying they're going to do a new file system, and we had one, and then we sort of killed it in 93, and then we moved the efforts to Colorado, and then that got going until like about 95, and then we killed that. And it seemed like for some reason we were just cursed. We could never do a new one. And we're thinking, too, about why is it so painful to administer storage? Because if you think about it, a disk is just a device that stores things, much like a DIMM, right, that stores memory. But it's a lot easier to deal with memory, right? Because if you want to add memory to a server, you just open it up, plug in some more DIMMs, reboot, and the OS starts using the added memory. All the apps go faster, and there's no real administration, per se. There's no DIMM config that you have to run. You don't create virtual DIMMs. There's no DIMM management software. There's no web GUI for it. It's just easy. And so we're just talking about this and saying, why can't it be like this for storage? A disk is just another kind of memory. It's just persistent. That does turn out to be a more significant wrinkle than I had realized. But we sort of said, well, why can't you just say, treat your disks as like a pool of storage, and you allocate from them with a memory allocator, because that's how you allocate things. And then just like you have, and that became the SPA, the storage pool allocator. And then just like in a VM system, where you've got an MMU, the memory management unit, to manage translations of things from virtual to physical, well, we could have a data management unit, a DMU, that would do the same thing in the file system. And then all that POSIX stuff that everybody hates, yeah, we'll just like put that off in some layer that sits on top of the thing below it. And that was sort of the genesis of the idea for what would later become ZFS. But this was in about 1995 or 96, and I don't know, I was in the middle of something else at the time. And I think you had just come on board, Brian, and I forget what jihad we were on at the moment, but there were many grand rewrites and multi-threading issues that still had to get solved. And meanwhile, there was a team that was, yet again, trying to do a new file system, and yet again, Sun didn't really quite stand behind it. And when that finally dissolved, it was around 2000, and that was like my breaking point. I just said, I can't take it anymore. I got to go scratch this itch. So I went to Mark Himmelstein, who was at the time the director of the operating system group. Ironically, EMC just acquired a company in which he was a manager. So, small valley. And I went to him and I said, we gotta try and do a file system from scratch for real. Here's the principles I want it to have. And I just want a small team. I want to have like 5 or 6 people tops, all in the same building, just focusing on this day in, day out. And he said, well, I'll tell you what, I'll make you a deal. I've got this group of about 80 people, what was called the data organization, and I need a data architect. So if you'll take that role, I'll let you go do the file system. So I thought, this doesn't really sound like a very good idea, but on the other hand, he kind of had my hands tied, and I said, all right, fine, I'll give it a shot. You're a seasoned manager, why not? What could go wrong? And what followed was the worst year of my career, because you can't just be, if you ever read Soul of a New Machine, you know the concept of signing up for a project, right? Engineers don't actually work on something. It doesn't matter if they have a job and get a paycheck. Engineers don't work on something unless they are interested in it. And they have to mentally sign up to work on your thing. So all of a sudden, I have 80 people that are supposedly going to work on ZFS. And of course, meanwhile, as far as they're concerned, they're still working on their thing. So I went, and it was like half the team was here, half the team was in Colorado. There were a few folks down in LA. And so I was just like flying around on planes all the time and trying to get momentum. And it just completely cratered as an effort. I was still trying to get it to happen, though, because I still thought there were some ideas worth pursuing there. And I had interviewed Matt Aarons in, I guess it was the fall of 2000? Yeah, fall of 2000. And we had made him an offer, and I knew that he was going to be starting on, I think it was July 20th of 2001. Right before then, my 3rd son was born. And so I had taken 6 weeks off to just kind of collect my thoughts, and I was really debating, can I actually stick with this? Or is it truly the case that Sun is just cursed? There is no way to do a file system here. Every antibody imaginable is against it. It's just a doomed mission. And I kept coming back to, yeah, but there's this guy, Matt, and I told him we were going to go do this, and I can't do that to Matt. That would just be so uncool. So you're the only reason, Matt. My sense of guilt. So Matt started, and I told my management at the time, we're doing a do-over. I'm not going to try and technically manage 80 people. It's just going to be me and Matt. We're just going to go off, be at the whiteboard all day, every day, go off writing code. And we started that in July 20th of '01. And by Halloween of that year, so only a few months later, we had our first working prototype. I basically wrote a little tiny pretend DMU to sit on top of the SPA that I was writing, and you wrote a DMU to sit on top of the fake, on a fake SPA that you wrote, and then we did the little merge of those two things, and we actually had something. There was no POSIX layer yet, but we were actually able to get an object store doing reads and writes, and then that was when we actually started to get on to really have some momentum. We brought on Mark Mabey and Mark Schellenbaum. We started doing the actual POSIX layer. Neil Perrin, who did our original intent log design. By October 31st, a year later, 2002, we had our first kernel mount. And then I believe it was October 31st of '05. That was almost when we integrated, or was it? That was the day, right? Halloween of '05, the day we integrated. And so Halloween's always been a special day for us. And we're now coming up on 10 years since then, which is pretty cool. I'm trying to be good on time here. Right? Got plenty of time? Jeff's story time. Actually, why don't I just open it up to questions a little bit for any sort of backstory, or everybody wants to chime in with their own little war stories. Kurt. Oh, time from first mount to willing to store our own data on it. Oh boy. It was probably a good year before we were willing to do that, and we didn't expose people to the sort of the Jurassic experiment where we put it on a server with real data until we were pretty close to integration. I think it was probably summer of 2005. Oh, right, yeah, before we did Jurassic, we did Zion, a matrix reference. We had lots of matrix references. Oh, and in fact, there's a little story that Matt mentioned, which is the storage pool that we had on Xeon was called Tank. And everyone thinks that it's like Tank because of IBM Storage Tank, that we're like using that name for the storage pool. It wasn't that. It was Tank was a character in the Matrix. And everything had Matrix. So we had another pool called Dozer, but that never caught on. Tank is in the man pages. That's true. Yeah. By the way, Kirk, I have to mention how surreal it was for me to be in the audience and listening to you give a talk on ZFS. It's just like, it's great. It just felt backwards. Yeah. Z-test, I don't remember if it was me or Matt, but we had the idea from the very beginning that we wanted to be able to test our code entirely from Userland because it's so painful when you're trying to debug stuff to go through the whole process of build a kernel module, install it, reboot the thing, and you made one stupid mistake, and now the thing panics. Now you have to boot from some alternate image and then come back up. The debug cycle is just really, really long when it involves your desktop crashing or even a test machine crashing. So yeah. So the idea with Z-test was we just wrote this program that essentially we took the DMU and SPA. If you think about it, all of that code really has nothing to do with the kernel per se. It's just code that says, I have a namespace that maps object and offset into some physical location. I have some physical space, which is really logical space that I need to allocate. And so we realized very quickly we could just create files in /temp, pretend that they're disk drives, and then issue all the read and write commands and transactions from our test program and exercise all the code from Userland. And the really big advantage of that was that it gave us the ability not just to test the data path, which is pretty easy to do with normal stress tests, but also to test the administrative path. So you could have things like, what happens if one thread is trying to attach a mirror while another thread is trying to detach it, while another one's trying to write, and somebody else is trying to resilver. And in practice, those things are very hard to test with actual hardware because it just takes a long time to do those things. But because we had very small devices that were really just temp files, which are super fast, and because the cost of killing Z-test and restarting it was measured in milliseconds, it meant we could crank through these scenarios really, really fast. We found all kinds of crazy edge cases that no customer ever had to hit because of that. Yeah? Ooh. So Z-loop is the thing that is a wrapper around Z-test that tells it what to run. And I don't know why it always kind of should have been integrated and as opposed to separate, but I know it was my, it was. Yeah, I was there for a long time. Ryan. Yeah, so the question was, why did we end up doing RAID as opposed to just mirroring? In the beginning, my thought had been that we would only ever do mirroring in ZFS because, for one, it's really easy. That's a huge advantage. The other thing was, though, that it seemed like, because of all the computation involved, it would make a lot more sense to just let disk arrays be responsible for doing RAID, and then ZFS wouldn't be in that business. We'll just let the array do it. But that was before I knew much about storage hardware. And what I learned along the way is that the problem with trusting the array to do RAID is that, for one, you're implicitly trusting all of the disk drives, and it turns out they actually give you bad data sometimes, which our checksums would routinely catch. And the other is that the array itself has a whole bunch of firmware and NVRAM and all these different things that it's using to make sure that it's keeping itself consistent, and any bugs in that can also turn into data corruption. So the issue that we had at first was we thought about trying to do like a RAID 4 or RAID 5 striping and realized that there was no way to make that transactional because you've got the write hole problem. And the sort of key insight there was realizing that instead of treating a stripe as it's a stripe of separate blocks, you can take a block, break it into many sectors, and have a stripe across the sectors that is of one logical block. And that eliminates the write hole entirely because even though if the write is partial, until all of those writes are complete, there's not going to be an Uber block referencing any of that. So you're fine transactionally. Yes? Okay. I'm sorry. I would say that that particular use case, the one of cloning source bases, was one that we did anticipate because before, before Git and Mercurial and Teamware and NSE Lite, there was the NSE, the Network Software Environment, which was a disastrous piece of software, but based on a cool idea, which was that you would have it's basically the same concept as any modern source code repository. Just the implementation had a lot of issues. But in particular, it had this notion that at the time, disk space was actually at a real premium. That was back when we were still selling like the 105 meg shoebox drives, right? And you've got that much LLC almost in CPUs today, not quite 25, but whatever. There was so much less capacity that there was a big focus on when you brought a child in NSE, it was essentially a clone of the parent, and the only things that got stored local to you were the things that you had actually changed. And of course, this meant that as you're pulling from your parent and it's pulling from its parent and so on, you become dependent on all these different machines for your build. And I think it was Butler Lamson who defined distributed computing as a machine in Wisconsin goes down and you can't get your job done. So we kind of knew that that was going to be a case where you have a relatively small amount of delta to a large quantity of data, and so cloning and snapshotting would be helpful. The other that we knew was going to be a big thing was for virtual machines for the same reason. Oh, sorry. Oh, BP rewrite. Okay, so one of the big debates that we went back and forth on was, in the early days, was should the pointers in our block pointer be virtual or physical? And we actually call them DVAs, data virtual address, but it's really not quite virtual. The device tree is virtualized, but your offset within it is the actual device offset. So it's not really a virtual address. You can't just arbitrarily remap things. And we did contemplate having just a purely abstracted address space, because what that would allow you to do is things like online defragging and deduplication, and there's a whole bunch of things that become a lot easier if you have that. The problem then becomes keeping track of all of these mappings. And we had, Matt could tell stories about the bolt-on, if you remember that, which is going to be basically this back pointer that we would have had to add it. And I guess there's a paper out now, we heard earlier, that supposedly makes that better. So that might be interesting at long last. All right, I'll be happy to answer other stuff later on today.